Hello, this video will help you understand problem number 27 in chapter 7. This one probably is the most difficult one out of your book. Um, well, actually not out of your book, but just out of your homework set this time. You're going to get more difficult ones when you do the energy unit. Basically, the diagram is given to you, so you can basically just change those cars into circles and you'd end up with something like this. Okay, the first one, MA, has a mass of 450 kilograms. MB has a mass of 550 kilograms, and those don't change. Whoops, whoa. I don't know why my fingers are setting that off more than usual. Then MA would be 450, and MB would be 550. Now the initial velocity for A, so I'm going to do NVA initial was a positive 4.50 meters per second. So that's this way. I'm going to say going to the right is positive. And VB initial is positive 3.70 meters per second. We do not know the final velocity for A or the final velocity for B. And we're trying to find both of those, which right now is kind of tricky, but when you learn the conservation of energy, it's not that bad. So there's two equations you need to understand. First equation you should take from the graph right away. So you go M1 V1 initial plus M2 V2 initial equals M1. I'm sorry, I said 2. It should be B. So A initial, and this is MA. Screw it, let's just do it from scratch. I didn't use A's and B's because I didn't pay attention to the picture they gave. I just did it my own way, so I'm trying to remember to do it their way. So MA times VA initial plus MB times VB initial equals MA times VA final. Let's make sure the final's big. Plus MB VB final. The other equation you need to use is on page 176. I'm using the format they give of V. They used V1 initial, so I would use VA initial minus VB initial equals VB final minus VA final. Now, you're not expected to understand that equation. You just are expected to read the chapter so that way you know where to find it. Or, be able to not be surprised when there's an equation that you need from the book. But the equation actually comes from conservation of energy. You're going to be dealing with that in the next unit. So, although you don't understand it now, you will understand it when we get into energy. Now, for part A, we're supposed to find the velocities, the final velocities, V A final and V B final. So, to do that, we're going to need to use both these equations, and the first thing, I think the most helpful way to go, is to pick one velocity to solve for. I think the velocity I'm going to solve for first would be VA initial. So I would subtract, as I said initial, I meant final, VA final. So I'm going to subtract this part over to the left. So you'd have M, whoops, hit MA VA initial plus MB VB initial minus MB VB final equals MA VA final. Okay, I'm not going to do anything else with that yet because the other equation is going to be using velocities. I'm going to isolate this other equation, so you make sure this equation here, I'm going to isolate that for VB final, so I can go ahead and plug in those values for VB here. So I would get VB final equals VA initial minus VB initial plus VA final. So now this equation does go in there. You would have MA VA initial plus MB VB initial minus MB times VA initial minus VB initial plus VA final. And then you have, whoops, equals MA VA final. Now, here you'd end up having to distribute the you'd end up having to distribute this M to all three. Okay? So you're going to have, I'm going to write this part on the left side now. So I'm going to start with MA VA final equals MA VA initial plus MB VB initial. Then you have minus MB VA initial. And then make sure you're paying attention to your signs. So you would end up having to add MB VB initial and subtract MB VA initial. So we need to add this part to the left so we can finally isolate this. So you have MA VA final plus MB VA final equals, is there anything we can cancel? Doesn't look like it. No. So you're going to have, well, we could simplify that. There's two of the same number. Yeah, let's do that just to save some room. So I'm going to say that this one and this one are just going to be added together. So we're going to have MA VA initial plus 2 times MB VB initial minus MB VA initial. Okay, now we can rewrite this left side as VA final times MA plus MB equals MA VA initial plus 2 times MB VB initial minus MB VA initial. Go ahead and divide by the total mass. You have AV final equals MA VA initial plus 2 MB VB initial minus MB VA initial all over MA plus MB. So that's VA final isolated for what we're looking for. Now we can finally plug in numbers. We get MA's 450 kilograms. VA initial was a positive 4.50 meters per second. Then you're going to add 550 kilograms plus 3.70 meters per second minus 5.5? No, 550. So 550 kilograms. And it was 4.5 for the, whoops, I should write positive. Plus 4.5 meters per second. Let's zoom out. Whoa, whoa, what? Okay. Plus 550 kilograms times a positive 3.7 meters per second. Barely fits. And all of that is divided by 450 kilograms plus 500 kilograms. 550, sorry. 550 kilograms. Okay, so that gives you a value of a positive 3.62 meters per second. To solve for the final velocity for B, we're going to go back to this equation here. So we're going to go ahead and, I'm sorry, no, yeah, final velocity, that's right. So we're going to have VB final equals VA initial, which was a positive 4.50 meters per second, minus a positive 3.70 meters per second, and plus the positive 3.62 meters per second we just found. So you get VB final equals a, whoops, that's annoying, plus positive 4.42 meters per second. Okay, so that's the answer to part A. Now part B asks you to figure out the change in momentum, if I remember correctly. Yep, change in momentum. Okay, now we could probably fit that on the top right here. So let me just, let's see, change the color. Okay, so VB was a positive 4.42 meters per second, and VA was a positive 3.62 meters per second. That way we can see it from the top. And part B, delta P1, let's zoom in so I don't waste too much room. So P1 I'm sorry, PA equals, and delta PB equals. So change of momentum for object A, change of momentum for object B. Okay. Now you should know that the change of momentum for A, delta PA, is just going to be MA times VA final minus VA initial. Okay. And for B, you're going to have delta PB equals MB with VB final minus VB initial. We can go ahead and have the values inserted. So we'd have 450 kilograms plus 3.62 meters per second minus a positive 4.5 meters per second. What the hell? Meters per second. Then close that. So you get a change in momentum for PA of a negative 396 kilogram meters per second. Okay, that's what 3 sig figs, so we're good there. Now obviously the change of momentum should equal, but you should still do it for mass B just to make sure they equal. So you're confirming your answer. You would have delta PB equals 550 kilograms plus 4.42 meters per second minus positive 3.70 meters per second. And yes, you do. You get delta PB equals a positive 396 kilogram meters per second, just as you should hopefully expect. Okay, so definitely one of the longer ones, partially because you have to use an equation that you don't really understand yet. But you needed to have an elastic problem that was complicated in order to prepare you for the test. So this was the one to give you. If you understand this problem well, then you should be feeling confident going forward for one-dimensional problems, and then we'll see how well you do with two-dimensional problems when we get to problem number 41. Alright, but that's it for this one.